Okay, so let's say you have an equation of this form. So where m is a slope and c is the y-intercept. So what that means is, if you have a graph, the graph will actually cut y-axis at this point, at that particular point. So if you have a function in a graph like this, for example, and you have got point Q and point P, on that interval, there is x1 and there's y1. This is the and there's x2. Similarly, there's also y2. So in order to find the slope of this line, there's a formula which says m y2 so this is for the formula for finding the slope of this line. So but what we are interested in today is something called the second line. So the second line is basically a line that cuts the graph at 2 points. For example, you have a graph like this, and then you have this is the second line. So the line is cutting 2 points of this graph. It's a quadratic graph. So if you move, this is point P, if you move point, this is, let's define the point. This is, you start from left, so this is P and this is Q. If you move point Q towards P, you end up forming something called another line that cuts the graph at exactly 1 point, and that is called the tangent line. So keep that in mind also. So let me show you the actual graph Yes, so this is just an example of a second line graph. So as you can see, the graph is this yellow graph is cutting the blue graph at exactly 2 points. That's an example of a second line. And an example of a tangent line can be something of this form. So this is an example of a tangent line. You see it's cutting the blue graph at 1 point, at exactly 1 point, somewhere around 1 here. Here. So this is called the tangent line. So we are interested to find the slope of the tangent line given a graph and the slope of the second line. So that's where we are going. So given the function, the formula for the second line is the one we already know, is given by f of x2 minus f of x1 where f of x2 is the y value of the second at the second point of the second x value, and f of x1 is the x value of the first point on the interval. You know, you have got that means our interval is defined by x2, x1, x2. This is our interval. So from this formula, for us to find the formula for finding the slope of the tangent line, now we derive it from the same one. So you assume that h is equal to x2 minus x1, like this denominator thing. So if you do that, then you are going to have x2 equals x1 plus h. So therefore our equation slope will be of where there's x2, we put this x1. So that will be the formula for finding the tangent, because as we were doing with the graph, moving the point Q to P, we were actually reducing the distance, reducing the difference, like here you have this, so you have this, so you have this point, now so you are bringing point Q to P, so you are bringing it, so you're actually making the difference, which is x2 minus x1 equals to 0. So if you do that, that's what if you are doing that, then we introduce something called the limit. You are not going to reach 0, but you are taking it closer to 0. So it's the limit of h as h goes to 0. So this is the formula for finding the slope of the tangent line. You actually take the limit. So the two formulas to keep for this are actually the following. Like at P. Sorry. At that point P. So point P means the first point, so we can just say at x x is equal to x1. So you take the limit as h goes to 0 of this thing. So these are the formulas that we need to keep in mind before we start solving some problems. Yeah, so that's it for this video. Then there will be solving questions, so we'll be using these formulas to answer some few questions so that we can understand fully what this really means. So goodbye for now, and make sure that you stick around so that we solve different questions together and so that we can understand. Goodbye.